Welcome everyone to the All Over the Map session. We're going to be talking about mapping. We're going to be talking about answering common questions when working with spatial data. But first, let me introduce ourselves. My name is Kent Martin. I'm the lead product manager for maps and spatial analysis at Tableau. I've been at Tableau for about 5 years now, and I think, even though it's only 5 years, I've been to 7 Tableau conferences, a couple in Europe, most over here. Sarah, why don't you introduce yourself?
My name's Sarah Battersby. I'm on the Tableau research team. I've also been at Tableau for about 5 years, and I have been to 5 Tableau user conferences.
Right on.
Okay, you want to get this started?
Let's get it started.
Yeah.
We have a very important question we need to answer. You see, first, Sarah and I were a little competitive.
And when he says that, Kent is a little competitive.
No, Sarah
goes along with it.
Last year, we did this session, and we asked people who had the better Twitter handle. Data Kmart versus Maps Overlord. And I will tell you, everyone voted for Sarah. That's a very good handle. But this year, we raise it up a notch, and we want to know who has the best fashion sense. Who has the most style? So, Sarah, is it the all-map shirt? What? What?
Kent does not get ruffled easily, and I have been planning this for weeks.
She told me it was going to be a Batman shirt.
Which is in my backpack right now as
You
my
tricked
decoy.
Me. What a decoy, Sarah.
Go team. Go.
Respect. So, is that a tie? All right, well, we got to break the tie tonight, a data night out. All right, Sarah, why don't you take a seat down there, and I'll get started with what we want to talk about in the session. Getting started. So this is an intermediate session, but it's kind of hard to hit the nail on the head with intermediate content. And a lot of people I speak with about mapping data and location data, sometimes they just need to know where to get started, where to actually get data from. So I mentioned a few things here on screen. If you want to work with spatial data formats, shapefiles, if you want to work with watersheds or census boundaries, especially in the United States, some of the best places to go are data.gov, which is like a big portal for all of the open data portals in the US, census.gov as well. And of course, if you're working with international data or humanitarian data, I recommend looking at the Humanitarian Data Exchange, where they have administrative boundaries for most of the rest of the world. Some of those data sets are hard to find. And then of course, pretty much everywhere there's an open data portal. I call out the UK here because I know there are a lot of attendees from the UK, but this data is available today, publicly available, shapefiles, GeoJSON, KML, all that stuff, you can all bring it into Tableau. So I'm bringing up the subject of data because I want to talk about a few specific things. And there's not going to be any more slides after this. I'm just going to do 2 demos. I'll bounce back and forth with Sarah. But to start us out, I want to show how to work with latitudes and longitudes before and after the 2019.2 release. Then I have a second demo, which I'm trying to tease here, which you'll have to wait and find out. But let's get started with some latitude and longitude data and a real question. So here we have neighborhoods for the city of Orlando in Florida. And my question is, I want to know which neighborhood has the most crime. Now I went to the Orlando Open Data Portal, downloaded this shapefile, and brought it into Tableau. And I can also go to that same website and download crime data. Let's take a look at it. We'll glance over here to the right. I'll zoom in a little bit. And I can see there's latitudes and longitudes. So I'm going to be able to work with this in Tableau. But it's in a single column, so I'm going to have to clean up the data a little bit to get started. Let's do it. So I come back to Tableau, and I'm going to make a new data source connection. Say new data source. I'm going to add a text file because I've already gone ahead and downloaded the Orlando crimes. I see my location field right here. Whoa. Okay, so what do I need to do with this column? I need latitude and longitude in separate columns, so it's real easy in Tableau. I can just go to the menu for the field and hit split. I hit update, and I can see my two new columns here are exactly what I need, except I need to rename them. Let's go ahead. I have latitude, I have longitude, and if I want to work with those automatically in Tableau, let's make the format and the geographic role correct. Don't worry, there's lots of nulls in the data set when it's sorted. Let's sort it this way. All right, so I know my data's there. Now, if I want to answer my question, where are the most crimes in these neighborhoods in Orlando, I need to combine the data sets, right? So now I have latitudes and longitudes, and before 2019.2, I needed to convert this data set into a spatial data set. Because to combine the two data sets, I'm going to use spatial join. Now, how do I convert a CSV with lats and longs into a shapefile? I use QGIS, a free and open source GIS tool. So let's jump to that just for a second. This is QGIS, and I can go ahead and add a layer from a delimited text file. I can browse to that file. Oh, I forgot one step in the middle there. I need to do the export from Tableau that included the lat and long. So I've already done that, and that's why I have this lat long CSV. I'll say OK. I'll set my latitude and longitude. I'll hit add, close. I can see the data, and now I just need to export it back out as the right format. From here, I can say export, save features as, and when I click that, I can see all of the common formats that Tableau can work with. So I could export it as a GeoJSON file if I want. I'm just going to close out the dialog because I've already gone ahead and done the export. So let's go back to Tableau. So now, if I go back to my original neighborhoods data source, I already have that GeoJSON file right here, and I can bring that onto the canvas. Let me zoom back out. And we'll let that load here, it'll just take a second. And then when I look at the join condition, I can see that Tableau's automatically recommended a spatial join, which requires the two spatial fields to execute. So I can zoom back out, and from here, answering the question, which neighborhood has the most crimes, is really easy. I go back to the sheet. Instead of having this color field on color, well, I can just replace that with number of records. And there I can see that the Florida Center has the most crime. So that's one way that you can convert CSV tables. You could also use Python scripts or other external processes to convert CSVs into shapefiles. Many different ways. But that was before 2019.2. At the 2019.2 release, we're making it really easy to work with lats and longs, so you don't have to go out to QGIS and do this conversion. Let me show you what I'm talking about. So let's go back to the data source. I'll pull the GeoJSON off the view. I'm going to add a connection to that crimes file that includes the latitude and longitude. I'll say yes. And now I can say, OK, geometry. Now, there is no geometry in this table. But in 2019.2, we added the function makePoint, which turns lats and longs into spatial objects so you can do this type of spatial aggregation. Looks good. I'll hit OK. I'll update the join condition to use intersects. And I'll come back to my viz. It will reload. And it should look exactly the same because it's the same data just without that conversion. And there it is, the Florida Center again. So we've removed that whole workflow related to QGIS, export, import, convert. And here we are working with the latitudes and longitudes directly in Tableau. So that was the first demo I wanted to show. The second one, if we go back to my PowerPoint, and I know you're all on the edge of your seat thinking, what does he want to make it easier to work with? Does anyone in here, you're going to have to raise your hand because I can't hear you, and if you're over there, wrap around the corner. Does anyone in here work with Esri or ArcGIS services or GIS systems? Raise your hand high so I can see. All right. So that's quite a few of you. And we know that the ArcGIS system is used widely in public sector, transportation and logistics, and a number of other industries. Well, we want to make it easier for you to work with your existing spatial data infrastructure. So here, I'm going to show you how to work with ArcGIS server data, not as background maps, but actually bringing in tables of data. We go back to Tableau. I'm going to say data, new data source. Now there's one specific caveat I have to tell you. We're building a new web data connector that will work with 2019.4, which was released last week. So if you've already downloaded and started working with 2019.4, this connector can work for you today. Talk to me afterwards if you want to connect and try it out. So let me show you how it works. I click on the web data connector. Right, I already have a connection that I've used recently. I'll click on that. I think I clicked on it. Yeah, I can see the web data connector is loading. We'll give it just a couple seconds here. I can see it says 70%. We need that to say 100%. Everybody turn off your Wi-Fi. All right, there it goes. Let me zoom back out. I'll paste in an ArcGIS server REST endpoint to a map service for a county in North Carolina. And I'll hit connect. Now Tableau right now is reaching out to a live connection to this ArcGIS service, which hopefully is still up and operating because this is a live demo. And it's going to review all of the tables that are available at that map service. It's supposed to take 18 seconds. Dang, maybe 22 seconds. There it goes. So here, through the web data connection, now I can start to work with spatial tables just like I always have in Tableau. I have building inspection zones. I'll jump into the worksheet, and whenever you're working with a web data connector in Tableau, Tableau always generates an extract of the data. So that's sort of standard operating procedure. I can bring out the shape field, zone onto color, and see my zones. If I want to perform the same type of spatial analysis, well, I can go ahead and add a second data source, choose the web data connector. Why does it always stall on 70%? We're going to have to dig into that. But I can jump over to my notes page, and I'm going to grab a different URL, copy, come back to Tableau. I mean, come on, I was supposed to kill the time there, copying and pasting that thing. All right. It's slowly loading up. There it goes. I hit OK, connect. Again, it's going to make the same connection. You can go to specific maps, and we'll pull out all the tables within that map, or specific feature services, and we'll connect to those as well. So now I can bring out the cases onto the viz. I can pick the shape field from both tables. Because I've updated the data source, Tableau is going to re-extract the data. And then I can go and visualize these cases, the incidents, all from this live web data source. I could make a 2-layered map here. I'll take zone off the viz. I'll replace the zones with the cases and dual access those, and I can start to explore this data. So we have a tighter integration coming with Esri ArcGIS Server services. Again, if anyone's really interested in that, make sure you reach out to me after the talk. Now, that's getting started working with data. I'm going to hand things off to Sarah for the next section, and she's going to walk through a number of really common use cases in Tableau, dealing with proximity and distribution and the like. Sarah, it's all yours.
Thanks, Kent.
Nice shirt.
Oh, thanks. Thought you'd like it. Okay. So, Kent just told us about how easy it is. Oh, I got to switch over here. Cool. So Kent just told us a bit about how easy it is to get data into Tableau. I'm going to switch over and talk about some common questions that you might want to answer in Tableau. But before Kent gets too comfortable, I want to do a little something to show everybody how exciting Maps is, because, you know, this is like the most exciting thing ever. It's Maps, it's awesome. But we're looking at folks with headsets on who are staring us down with these steely eyes, like show us something cool. So we need to get something a little bit interactive before I do some use cases. I want you to show everybody here how cool Maps are and how much fun you're having, and we're going to do the wave, and everyone's going to walk around being like, what are these folks doing? So we're going to start from this side,
hey, Sarah,
over here.
Sarah,
yeah.
We're a little competitive. We want to show 2B how much fun we're having in DataCube 2A.
So all you guys over there, I'm pointing at you, the folks who can't see me directly most of the time, you're going to be doing the wave too. Okay, we're going to go all the way around.
Am I going to start running?
You're going to start running. 1, 2, 3, go! Woo! I'm looking at you guys over there. Okay, now let's take it back the other way.
Come on back!
Come on, back the other way.
Yeah.
Woo! All right.
That was
we
the
even got
silent
part of
wave.
2B to do it. We got part
That
of
was
2B
the
in
quietest
on this.
wave I've ever seen. Look at it, they want in.
All
I
right.
bet you 1 or 2 of them will walk
Maps
over to our
loves
session.
2B. Okay, thank you guys so much. So what I'm going to do is I'm going to jump in and start talking about some of the common types of spatial questions that people want to answer in Tableau and how you can use some of the existing functionality, new functionality, and think about your data in new ways. So first thing I want to talk about is how is your data distributed? Because this is generally your first line of attack. So I'm going to use a data set of point locations for fire incidents in Las Vegas. So I'm just going to drop these on the visualization. And I'm going to go ahead and separate those out, disambiguate them. Because you know Tableau loves to aggregate. So we've got about 200,000 data points, which is a couple years of incidents that the fire department responded to. And we're going to talk about this question of how is the data distributed? Well, it's kind of hard to tell with this data set. There's a lot of data, but it's not a huge, gigantic data set. This is only about 200,000 points, but it's still hard to pull out a real pattern of where the greatest concentration of calls that the fire departments are responding to. So let's look at a couple different ways that you can start to pull out spatial distributions to really understand what's going on in your data set. So the first thing I'm going to do is the super quick, let's just get a good ordinal sense of more stuff, less stuff, where's the greatest concentration, and we're going to use the density mark type in Tableau. So here's that same point data set. There is no way that you can look at this and say, I know where the most calls are to the fire department. But I can change the mark type to density. And this is going to quickly give me an aggregation, a smoothing of the surface that says, I know where all the points are overlapping, I know if there are 70 points in exactly the same place that you're not going to see even if you zoom in. And Tableau is going to do some smarts and say, I can pull out the greatest concentration. And we can zoom in, take a look at this little spot over here. And it turns out there's this nice linear feature. That happens to be Las Vegas Boulevard. Turns out the fire department comes here a lot. I don't know what's going on, but it's probably because there are a lot of people, to be honest. And because people are doing crazy stuff in Las Vegas. But one of the things about this mark type is, it's going to give you a really fast view of greatest concentration, but it's also just going to give you an ordinal level view. It's giving you this relative more stuff, less stuff. It's not breaking your data down into what I would call like little polygon containers, where you can say, I know exactly how many things are in this place. So let's look at some other techniques that you could use to explore density in a different way, or to explore distribution in a different way. I know with this particular data set, the fire department aggregates everything to intersections. So there are a lot of points that get stacked on top of each other. That's one way they anonymize. So I can take advantage of that in this data set, and I can just look at, here are the locations at the intersections, and I have them, the level of detail is set to the latitude and the longitude. So now instead of having a bunch of points stacked in exactly the same place, I have one point, but that point is smart, and I can drop number of records on size, I can drop number of records on color, and I can see the specific intersections where a lot of data points are stacked up, highlighted really quickly. And one thing I can do here that I can't do with the density mark type is I could actually grab one of these points, and I'm going to go ahead and drop number of records on my tooltip. I'm going to go ahead and turn my tooltip back on and add number of records, and make that a really big number so you can see it. I know at this specific location I have 1,800 response calls. So I can pull that out quickly from this proportional symbol mark type, and I can't pull that out quickly from density mark type. So it's given me another way of looking at the data. But maybe we don't have data that's all stacked up in single locations like intersections. Maybe it's distributed out a little bit more, and we want to see more of a smooth, continuous pattern, but we still want absolute values for geographic areas. A quick way I like to do that is converting my data into square bins. So think about just dropping a big set of squares on top of your data set and saying, tell me how many things are in this square, in this square, in this square. You can approximate that super quickly in Tableau with calculated fields. So I've gone ahead and pre-calculated these, and I'm going to show you, all I'm doing is I'm taking the latitude value and the longitude value, and I'm using the rounding function in Tableau. And that's going to round me down to different decimal levels of precision of my data. So think of, if a decimal degree is like 110 kilometers, 1 decimal place of precision is going to be what, like 1 kilometer, 2 will be 10 kilometers, 3 will be 100 kilometers, whatever. That was really bad math and it was totally wrong, but I think you get the point. Keep chopping the decimal places off, you're going to get different size squares that you're aggregating your data into. So we can do a quick calculated field. I'm going to replace my latitude and longitude on rows and columns with these new calculated fields. And I'm going to go ahead and change my level of detail to this ID that I've created. We'll use a square mark type. So even though this is aggregating into roughly square units, it's not giving us an actual square polygon. We're just getting square marks. But I can size them so they look decent on the map, and drop number of records on. And now I have a count in each of those square units, and I have a different way of looking at density and how it changes, or how the concentration changes across space. Now, because this is a calculated field, I can also control the size with a parameter. So this is rounding to 1 decimal place of precision. I could round it to 2 decimal places of precision, resize those squares, and see a finer level of detail for how my data can be aggregated across space. Now, a problem with this is I'm just using square marks. I don't actually get to see the polygon where the data is being aggregated. But we can use the spatial join functionality that Kent showed us and bring in a data set like this one that I've created of hexagons. I love hexagons. I like hexagons a lot more than square bins. And the main reason is because I think that they are hipper and edgier. I know that you guys were all laughing really deeply. You just, the headset throws you. So I made this set of hexagons, and I'm using a spatial join in Tableau. I'm just taking my hex bins, and I'm joining them to my fire incidents. And I'm going to go ahead and change this back to an inner join, because we don't want all the hexagons where there are no points inside them. I'll go back to my worksheet, and now all I'm left with, here's every bin that had any point fall inside of it. I can drop number of records on color, and now I have some polygons that I can zoom in and out on. I don't have to resize it all. And I can get an absolute count for any one of these polygons. Once I redo my tooltip real fast, drop number of records back in there, make some nice big text. I know that in this exact geographic location on my map, there were 3,700 calls. I could then take that and pair it up with other elements on a dashboard, for instance, and start to do some interactive analytics. So I could pick one of these locations, see all of the fire stations that have responded, how many calls they've responded to. So I know station 1 responded to 2,500 calls in that location, and 3,600 of them were medical. I could also turn this around the other way. Instead of clicking on the hexagon, I could say, click on station 1 and say, hey, here is every location that station 1 responded to. And then I could dig in from that side as well. Another way that we can look at the distribution in our data is by using shape files that have polygons or geographic areas that have specific meaning and interest. So we looked at some square bins and some hex bins, and those are cool, but they may not be the geographic region that you're interested in. You may care about trade areas, school district, health zones, census tracts, whatever the polygon shape is that you want to aggregate into. You could just bring that shape file in, do the same spatial join, and these are city council districts, and just drop a number of records on, and then you can see your pattern aggregated into those polygons that have deep meaning for your data set. So those are a number of cool ways that you can look at distribution, and what I'd recommend is when you're first starting to explore your data, use as many of them as you can, because they're each going to tell you a little something different about how your data is distributed. So now I want to jump over and look at another question real quick. We're going to look at the question of what is there. Because when we talk about distribution, we're talking about this overall pattern through your whole data set. But sometimes you want to be able to drill in and look specifically at the context on the ground for individual data points or individual regions on your map. So I want to show you a few ways that you can do some neat stuff in Tableau. The first is just to take advantage of what we have built into our base map. So let me show you with this data set. I have building permits for Las Vegas, and they're all really exciting things like HVAC changeouts, offices, etc. Meter tags, there's really good stuff in here. It's exciting data. I like this data. Back in the day, I did an internship at a planning department, and I did a lot of residential permitting. There was a lot of growth in the city, and I got tasked with going out and taking photos and figuring out the context for all of these vacant places where there were going to be new buildings created. I drove around a lot, taking a lot of pictures. I was like, oh, it was so great if I could just add some more context onto my map, figure out what's there, maybe not have to go out on the field. So we can do some of that in Tableau just by looking at the map layers. And I'm using our streets data set because it has a lot of really nice context and gives me a really nice contrast to see these point locations. And I can add in points of interest. And I'm going to zoom in, and we can see some new detail starting to show up, like the Stratosphere Hotel Tower. Oh, we got the locksmiths. We got Carl's Jr. I mean, we got everything on here. This is great. And this is just detail that's built into the base map. And if you noticed when I zoomed in, we're also starting to get building footprints. So that's some nice context that you can use to understand what's on the ground underneath your data. But I want to show you one more thing that we can do that adds a little extra context to your map. You can pair this up with something like Google Street View. So I have latitude and longitude coordinates in my data set, and I have this set up with a URL action and a web page that I've dropped onto my dashboard, and I can pick any one of these locations. Like, I really want to know about what's going on at this location where they did a water heater. I've set up an action where I can click where it says Street View. This is going to go out to Google and say, hey, tell me what's on the ground right there. So if I had had this when I was an intern, which, by the way, I think was well before Google Maps existed, so I wouldn't have been able to do this. I know I just dated myself a little bit, but this would have been awesome. I wouldn't have had to go out and drive and take a look at each one of those properties. I could be just like, hey, call up Street View. I got my screen captures. I know what's on the ground. I feel good about this permit that's being issued. This is super easy to do, and I have put something up on GitHub in case you want the code to do this. It's just an HTML page, and I'm actually running it with a little Node.js server that I've got on my laptop. So if you go to GitHub, my username there is Sarabat. I have this whole folder of random Tableau scripts that I've written, Python stuff, JavaScript stuff. I just kind of write stuff. Stuff hanging out. Go into the Street View folder. You can just take this HTML file. The important part is where it says your API key goes here. Go out to Google, get your own API key. Drop that in when you put your HTML page somewhere. And this should just connect you straight into Street View, grab that image, and let you drop it into your dashboard. So the last thing I want to talk about is the question of how far away things are. Because how far things are is a really important spatial question. Whether you're talking about how far your customers are, your warehouses, or how far away each incident is that the fire department's responded to. So I'm going to dig into these with that same fire data. We've got incidents, we've got fire stations, we've got both of them on the same map. Because this data set, every incident happens to know which fire station responded to it, I can use a real quick highlighting action in Tableau, and I can just click on a station and say, show me the distribution of all of the calls that this station's responded to. I can see how they cluster. I can see how far away they are. I can get a good visual sense of how far away. But I may also want to get a real analytic sense of how far away. So we're going to do a quick calculation to look at the average distance between each fire station and all of the incidents that they responded to. Now, since Kent showed you a little bit of how you used to do it and how we've made it easy for you, I'm going to make your eyeballs burn with a little bit of trig real fast, and then we're going to talk about how easy it is to do now. So this is how I used to do all of my distance calculations in Tableau. Is that one nice? Oh, I had to copy and paste this every time I wanted to use it because Lord knows I could not get my arc cosines and my sines and everything in the right place. It was tough. But I could drop that on my viz. I could change that from sum over to average. I'm like, cool, I got the right value. How do I do that now? Let's open up this new calculated field. This one's a real hard one. Okay, distance. I've got the geometry for my incidents. I got the geometry for my fire stations. And I want that number in miles. I no longer have to remember the radius of the Earth in miles and kilometers. I can burn that sticky note on my desk because I can just type in the word miles or MI. And if I don't have geometry already, I can use make point. Kent showed you using make point to take a latitude and longitude value. So you could do this with 2 CSV files that just have a latitude and longitude column. It's awesome. So that new calculation, let's just drop that onto our viz. And I'm going to change it from sum to average. And you guys are going to be totally amazed because the values are the same. But it's a lot faster and cooler to use the distance calculation. So we could then use that, and we could put it together with our other visualization, and we could start mining through looking for patterns. Now, one of the ones that I really like that jumps out at me is we've got station 102. The average distance from the stations to their calls is normally less than 2 miles. There's something about station 102. 5.83 miles. I can just click on that, have it show up on the map. I can see the distribution. I can say, what in the world's going on? Does anybody, I don't have a headset on, so I can hear you if you yell it out. Does anybody have any idea what station 102 might be? They're a very special station in Las Vegas. Oh, I heard a medevac. I'm guessing that's the universal helicopter sign. Turns out this is the bomb squad. So this is like the official FBI certified bomb squad arson group, and they travel all over Nevada, Southern California, and they do stuff that you do not want them responding to if it's your home. But that's a pattern I probably wouldn't have pulled out real quickly unless I started looking at the distances and the distributions. So some of the other cool things we can do if we want to look at this question of how far away things are, I've got this dashboard or this workbook built up where I can pick out a station, and it's going to highlight everything that's within a selected distance. So it's a little bit more complicated here, and I'm not going to build it up live, but I'll tell you how this is built. I know where the station is located. I know where all the incidents are located. I have a parameter action that updates the selected station whenever I click on it. When I click on that station, it changes a parameter that says latitude of selected station, longitude of selected station. That parameter goes into my distance calculation, and that drives my highlighting. So let's look at that calculation, because it's pretty straightforward. I say, give me the distance from every incident to make a point of the latitude and longitude of my selected fire station. These are parameters. And then give me that result in miles. That's all there is to it. I then run that into a set. So I say, now give me a set that says I'm within the interested distance, I'm outside that distance. I drop the set on for color. And that gives me something that is dynamic, and I can change the search area. So show me everything within 5 miles, 4.5, 4, 3.5, 3, dynamically updating. I could combine that with other visualizations, so if I want to know how many incidents are in that set or outside of that set, shows me a little bit about the concentration of points. I can put that together on the dashboard and make this dynamic. So I click on a station, and now I know what proportion of all of the calls are within 3 miles of that station. One last example. We're going to look at how we can use the make line calculation to emphasize some of the distances on our map. So instead of just looking at the individual point locations, sometimes it's really nice from a visual perspective to give people a little bit more of a hand hold, or maybe an eye hold if you want, to say, where is my point of interest and how does it connect to all of the incidents that are real interesting to me? So I'm using make line. Instead of just drawing the point, I'm rendering a line between my selected station and each one of the incidents that it's responded to. And I can change dynamically using the table on my visualization. So it's just a nice way to emphasize connectivity. It also adds a little bling, and you may have noticed Kent and I like our bling. Okay, with that, I'm going to go over, hand it back to Kent. He's going to show you some more cool stuff.
All right. Thank you, Sarah.
Boom.
You can hear me all right? Back on? Cool. Showing the right thing? Great. All right, so in Sarah's last example, she was talking about proximity and distances and ways in which you can use calculations to understand which things are nearby and which things are not, right? Well, if you tuned into Devs on Stage this morning, if you're at that keynote, you saw us talk about a new spatial function called buffer, and I'm going to preview that here and just talk a little bit about it. So if I wanted to look at these fire stations in Las Vegas and understand what is the 1 mile radius around these fire stations, I can do that easily with this buffer calc. Let me show you how to build it. This is our station's buffer. And now I can just type in buffer. It's a function. Hit tab. I'm going to use my stations, a unit of 1, and I'll say miles. I'll zoom back out, say OK, and now I have this spatial object which is based on an actual distance that I can bring onto the view. Let me flip this over to the map mark type, and I'll take my station's buffer and replace that on the view. And now I have an actual distance base mark, right? And so just from looking at this, I get a sense of one other thing, right? I can see that overlap between stations, where some stations might compete or have to decide how we respond to calls. You could also imagine that this wasn't fire stations, but what if it was nearby Starbucks, and you wanted to ask a question about cannibalization of your, for your customers, right? You don't want to place too many retail stores nearby. So it's a good way to explore spatial data, and obviously it's a great visual for understanding that distance. When Sarah was showing that dynamic distance calc, you could kind of see the shape of a circle, but that's with really dense data, right? There were 200,000 points in that data set. If the data is a little bit more sparse, you kind of lose the sense of the actual shape, the actual boundary. So what if I have the next question? I want to see both the incidents and the stations as it relates to this 1 mile buffer. Well, like I mentioned earlier today, if you want to see two different spatial data sets that are coming from just latitude and longitude tables, I mean, how are you going to combine them together, right? I mentioned with spatial join, you need to have two spatial files to do the join. And then we added make point, so you needed to have your boundaries, and you could generate the point object. But now, with buffers, you can generate the boundaries and the points. So let me show you what the data source looks like. And again, it's real simple. I have the buffer calculation generating the one side of the join. I'm using intersects and make point on the other side of the join. The one really important part about this is that you no longer have to work with and think about shapefiles and GeoJSON and these spatial data formats. You could have two Excel worksheets that have latitudes and longitudes, or two CSV files. So it's really spatially enabling these traditionally non-spatial data sources. So let's get back into the view. And let's see both the incidents and the buffers at the same time. Again, I'll quickly make a dual axis map here. All right, I have my incidents, and I'll take off the station number and bring on the row number and maybe make those blue. Okay, so now I can visualize it, and you can see how just this visual is a little bit different than what Sarah was building, right? Like you can imagine this buffer over here where there are no incidents, but I can definitely see the full enclosure of the distance that I'm interested in. Again, just a great visual analysis technique. But it's made possible because I can aggregate and join these two tables together. Now what if we want to add some of this dynamic interaction where I reduce the size of the buffer and it also reduces the incidence at the same time? Well, let's see how that works. Hang on, let me go back and for the buffers, let me look at the buffer geometry and make sure that my station buffer, okay. I'll zoom in here. Yeah, and I'll just show you, in this case, I've used this calculated field, or in this calculated field, I'm using a parameter so I can dynamically update the buffer, right? So I'll zoom back out, say okay. I'll show my buffer distance parameter control. Let me just bring that over here. And now I can dynamically update the size of the buffer. But you might be thinking, well, what about those points? Why aren't they staying inside the buffer, right? Well, let me kind of give you an overview of what's happening. In this case, I have two views. On the top view, I have the map that I was just working with, right? And in that map, it's just the result of the join. And the join was based on a 1 mile buffer. I can't stick a parameter into the join condition. We should make that happen in Tableau. But until we do, I can't do that. And I visualize this using a set. So I have gray marks that are outside, blue marks that are inside. But beneath, I actually have a dynamic calculation, much like Sarah had showed earlier, where I can compute distances at the same time. And this way, when I alter the buffer, you'll see that both the buffer and the marks update. I'm happy to share any of these workbooks or calculations. I know afterwards Sarah will also make her workbooks available for those of you who are interested in the resources and want to pull the workbooks apart and see how it was built yourself. So that was the last demo I wanted to show in discussing proximity. Let me just jump back to the slides, and I'll give you a few items, food for thought, as they say. So we've gone through the demos. I want to talk just a little bit about the future and things that we're thinking about and that we need your feedback about. So obviously we want to really allow you to answer more location-driven questions, right? We know this is very important. Obviously look at the number of people here, but we want to, we start with that first pillar, right? You need to be able to connect to your spatial data sources. So whether it's these ArcGIS services that I mentioned earlier, but you might have spatial data in Google BigQuery or Vertica or some other database. I'd love to hear that feedback from you while we're at the conference. More spatial functions. So we've shown this year we've delivered make point, make line, distance. We also have a variant of make point that can take projected coordinates and transform them back to latitude and longitude. So if you work with a spatial reference system that's projected, like North Carolina State Plain, which is in feet, you can convert those XY coordinates into projected coordinates. And of course, we want to continue to add these calculation functions because they're all really like building blocks, right? You can see how they work with sets, parameters, other calcs, really allowing you to do so much and be so flexible with your spatial analysis. Then there's the more than 2 layers thing. Has anyone thought about or wanted Tableau to support more than 2 layers before? It's a popular subject. This is one thing that we're doing a lot of research on and spending some time doing some development. But again, I want to take this opportunity for you to give me feedback or to go over to the Data Village where we're running a lab, an actual TC lab that explores prototypes of map layers. So if you haven't done that already, maybe go check that out. And then, we want to continue to bring spatial across the Tableau platform, and I'd expect us to deliver spatial and Tableau prep, making it easier to clean and prepare spatial data sets in the future. So those are things that we're thinking about. I'm not promising anything. I'm not allowed to promise things, but this looks like a pretty accurate view of the world to me. And then if you want to continue to give us feedback and participate with some of the prototyping and early releases that we're doing, I recommend everyone go to prerelease.tableau.com where we have early versions of Tableau so you can use them, validate what we're building, provide feedback. It's not just for spatial and mapping related features. From the keynote this morning, you saw animation. There's been an animation pre-release, which we've collected feedback from hundreds of customers. So thank you if you participated in that. And then of course the community. For those of you who are on the forums and asking questions or responding, but also if you have feature requests, you have things that you want to see or use cases you want to share, and you want the community to sort of back you up, you can post your ideas on the ideas site. And I can tell you a lot of the work that I've done since I've been at Tableau has come from some of those ideas that have been posted on the site. So we really do value it and use it as a data point for making decisions. And then you can always feel free to reach out to Sarah or myself via email or Twitter if you have a hard question you're trying to get through, or you just want to reach out and share some of the work that you're doing and maybe your use case to help us be more educated about what you're doing. That's a great way to do it. And then just to wrap up, Sarah, do you want to just talk for just a minute here about your session? I think, it's tomorrow, last session of the conference. End the conference with a bang and talk about some spatial SQL. What's going to happen in that session?
So tomorrow I'm going to be giving a session on how you can augment your spatial analytics by taking advantage of the spatial operations in databases like Postgres or SQL Server. And do pretty much anything spatial you want. So long as you can write a spatial query using SQL, you can run that right back into Tableau. So I'm going to go through a lot of different use cases on that tomorrow and show you some turbocharged analytics.
Awesome. Stay up here, Sarah, just for a second. A quick reminder, it would really help us if you could fill out the survey. I think it's in the app. I hope it's in the app. If you could do that, that would allow us to make these sessions better next year. And then one more thing, if there's any questions that people want to ask about the content in this session, not about all the other things mapping, but just what we presented, you can come up here and ask a question at the mic so that people with headphones on can hear you. You can do that now, but I just want to say thank you to everyone. And after Q&A, we'll stick around and answer more questions. So thank you.